Hello friends, this lecture is about processor management, job and scheduling. We need to understand that processor management is the most important part of the computer. Processor is the brain of the computer. It does all the important and the unimportant functions that are carried out in the computer. It is also the most expensive resource of the computer, so it has to be seen that it is optimally used, and this is done by the operating system. Scheduling is done in three levels. First is high level scheduling, which does job initialization. Next is intermediate level scheduling, which involves activating and suspending. Low level scheduling, which involves dispatching process. Priority can be assigned automatically by the system, or they may be assigned externally. They may be static, or they may be dynamic, or they may be purchased. Static priority do not change. Static priority mechanisms are easy to implement and have relative low overhead. They are not, however, response to the changes in the environment. The changes might make it desirable to adjust a priority. Dynamic priority mechanisms are responsible to the change. They are more complex to implement and have greater overhead than static priorities. In purchase priority, an user with a rush job may be willing to pay a premium, that is purchase priority, for a higher level of service. And the job scheduling is divided into two types. One is primitive scheduling and another one is non-primitive scheduling. In primitive scheduling, the operating system can decide on the previous job or the next job before the previous job is done. In non-primitive scheduling, the operating system will wait till the current job is finished and then only can decide about which job is scheduled. The simplest scheduling is first in first out scheduling process. They are dispatched according to their arrival time on the ready queue. Once the process has the CPU, it runs to completion. Now there enters a process P1, then P2, and then P3. P1 moves to the running state, allowing other process in the queue to advance. When a process finishes, it can exit from the system. Shortest job next scheduling. That means that it will take the shortest amount of time that will be scheduled first. Shortest job next is advantageous because of its simplicity and because it minimizes the average amount of time each process has to wait until execution is complete. Deadline scheduling. A job whose deadline is moving large. For example, if I have to be done in an hour, then I will do that first because the deadline is today. And if a job has to be done 2 days later, then I will forget about it till the deadline comes. In round robin scheduling, that the process time is divided into small time slices. Each time slice is divided and the program that are waiting to be executed wait till they get their own time slice. Now all the time slice is equal opportunity mean that if job 1 has got one time slice, it execute till the time slice is available. Only then the job 2 will come. When a process time slice ends, the process is sent back to the back of the ready list, allowing another process to take place in the CPU. This highest response ratio next scheduling is that elapsed time by execution time required. In this, shorter response time gets the higher priority. Another important kind of scheduling is multi-level feedback queues. Input and output bound processors normally use the CPU only briefly before generating a input-output request. CPU bound process might use the CPU for hours at a time. It is mainly available on a non-primitive basis. By this lecture, you would have learned about what is processor management, job scheduling, and its types. I hope this lecture would be useful for you. Thank you.